So being able to identify the difference between categorical versus numerical data will kind of open up to how we can just start describing the data and what we can calculate from it. So we have these quantities of interest. If we have categorical data, that's where we can talk about a proportion, which also relates to the idea of a percentage. Often we calculate it from taking a fraction and then changing it into our percentage form. If we have numerical data, all we're going to talk about right now is calculating a mean from it, an average. So mean and averages, same thing there. So this is where we go back to that discussion of population versus sample data, and we need to know what type of data we actually have. And with that, when we calculate these numbers, once we get this final number out from what we're talking about, we use different symbols of population versus sample. And with this, I highly recommend having somewhere in a notebook or just a piece of paper, just have a page for notation, because we're going to be getting all of these symbols, and while both of these symbols represent an average, they look completely different, and it's because of where they're coming from. So it can be helpful to have just a page of the symbols and what they represent, especially when we start making formulas that plug in these values. So we use P if we're taking a population proportion. So if we get some percentage from a population, we use the symbol P. Like if I was interested in the proportion of Americans that have blue eyes, this would mean, and say we got out the number 17%. So P equals 17%. What that would tell me is that I talked to every single American out there in the world, and I took the proportion of blue eyes, and it was 17%. So that's where it's coming from, a population. It was very difficult to obtain, and we got that number out. Which means if we see P equals a number, it's exactly correct, because it's coming from a population. Whereas if it's a sample proportion, this would mean maybe I talk to 100 Americans and take the proportion of blue eyes, maybe I get out like 19%. So it's close by, but not exactly the same, so there's a little error there. We'd use the symbol P, and it's like this little carrot top on it. We call this P hat, because it has a little hat on top. And we use this symbol, so seeing P hat equals 19%, that tells us we found this proportion, and because of that symbol, it's coming from a sample. That tells us there's a little error involved, but it should be close to what's happening in the population. Similar idea here when we're calculating averages. We take a population mean, so like in our previous example, if we took the heights of all PCC students and calculated the average, we use a symbol, and this is called mu, like a cat, mu. And it's a Greek symbol, and this would just tell us that if we found some height and we attach the symbol, that means we talked to everyone, and that was the average. If we use a sample, so for a sample mean, we use the symbol X with a little bar on top, so you can say X bar for this. And that would be if I just talked to, say, 50 PCC students, collected their heights and averaged them. I'd want to use that symbol to show this should be close to the population, but there might be some error involved. So having these different symbols, and they're often going to break all throughout our class of the population symbol versus sample symbol, because they'll represent the same sort of calculation, but it'll be more descriptive in terms of where is it coming from and what kind of level of accuracy is attached to it. So to kind of practice once more at this idea of population versus sample, and now mixing in this idea of proportions versus means, say we want to look at the percentage of a city that supports a new recycling law, and we want to get this idea of population versus sample in there. So we want to know is, are we collecting categorical data or numerical data? So with that, if we put ourselves in the shoes of the researchers, like what are they asking the people? And it would be whether or not they support the recycling law. So like, do you support the new recycling law? Which in terms of their answers, it's just going to be yes or no. So they'll be saying yes versus no. They either support it or they don't support it. So with that, we have categorical data. which means we're going to calculate a proportion. This kind of leads to our first row up above. We're going to be using these symbols and this idea of calculating percentage, which makes sense since they asked about what percentage. So, population versus sample. To get an idea of a visual, our population is the big thing, and then this sample is the small part of it. And if we're calculating proportions, if it's coming from the population, that's where we'd use the symbol p. If it's coming from a sample, we'd use p hat. So if we calculate p, this is where we would talk to all of the residents in the city. So we're talking to all the residents, and then we calculate the proportion that said yes, how many of them supported the recycling law out of everyone that we interviewed. So this would be the percent of all residents that support the new recycling law. And then, in contrast, if we had just taken a sample, so this would just be some of the residents. If we just talk to some of the residents and take this percentage, then we use the symbol p hat. So this would be the percent of sampled residents that support the new recycling law. So that's how we can see the difference between population versus sample, and describing the same percentage of residents that support the new recycling law. Is it just the percentage of all, or just the percentage of some? And that will change our notation. With this one down below, where we're looking at the average days of shelf life for an apple at Whole Foods, if we, again, put ourselves in the shoes of the researchers and what we're recording, this would be like if we visit Whole Foods each day, have some apples that we're kind of monitoring, and as soon as an apple would go bad, that's when we'd write down the number of days that it lasted on the shelf there. So what we'd actually be writing down is we'd be recording the number of days, which means we're recording down numbers, so we have numerical data, and with that, something we could look at is the mean, which makes sense again because they use that word average there. You won't take averages of categorical data. You can't really take averages of words. So with that, the mean's going to strictly be with numerical data. So population versus sample, kind of similar picture drawn here. It doesn't change. Population is the big thing. Sample is the small thing. And this population would be if we looked at all of the apples, all apples at Whole Foods, which sounds pretty impossible. So we might, if we were the researchers, we'd probably have to rely on a sample, but that's what it would represent. The sample would just be some apples at Whole Foods. So if we're taking this average, we took this average shelf life of all apples, then we use the symbol mu. If it's just coming from a sample, then we'd use x bar. But both represent this kind of average shelf life. So mu would be this average shelf life of all apples at Whole Foods. Whereas if we have a value for x bar, this would be the average shelf life of some apples at Whole Foods. So that's some things we want to take away from these is difference between population versus sample, how the type of variables determine what we can calculate in terms of proportions versus means. So what we want to talk about further is how do we collect the data? How do we actually get this information to start analyzing it?